Hi everyone, welcome to this video lesson today. We are going to be looking at limits of accuracy and error intervals, which is a topic some people find a little confusing. So I'm going to try and simplify this as much as possible to help you out. If you want to have a go at any of the questions that I put on screen today, and I always advise you do, practice is the best way of helping your understanding in these areas, then grab yourselves a pen and something to write on. There's the option to have a calculator if you've got one to hand, but you don't necessarily need one, and often questions like this will be on a non-calculator paper. I'm going to jump right in, so if you need a little bit longer to read the task board, pause the video and hit play when you're ready. So limits of accuracy, otherwise known as bounds, you might have heard both of these terms, and when we talk about bounds you might have heard lower bound and upper bound. They both mean the same thing. The limits of accuracy of a number are the range of values a rounded number could have been before it was rounded. So if you imagine you've got a number and it's rounded to, let's say, the nearest 10, we're looking at the range of possible numbers that could be rounded to that number. The lower bound is the smallest value it could have been, and the upper bound is the highest value it could have been before being rounded to this number that we've got. Let me illustrate that for you. So all I know is a number has been rounded to the nearest 10 and I got 230 when I did that, but I don't know what the original number was. The limits of accuracy tell me the lowest and highest possible number that could have been in order to be rounded to 230, because obviously not every number will round to 230. So the lower bound of this number is 225. If I said to you round 225 to the nearest 10, you would tell me 230. Whereas if we went one lower and we went to 224 and rounded that to the nearest 10, well, that one would round to 220, not 230. So that's how we know that the cut-off point is 225. That's the lowest number that when rounding to the nearest 10 will get to 230. Now, if you're not comfortable with rounding, I have got another video on rounding, which I will link up above. So if you'd rather go away and watch that one first and then come back to this one, that might be quite helpful if rounding isn't one of the things you're most confident in. And then we go to the upper bound. So 234.9 recurring is technically the upper bound, because if we went a tiny bit higher to 235 and rounded that to the nearest 10, that would round to 240. So again, there's that cutoff. So when rounding to the nearest 10, we can see that 225 is the lowest number we could be, and 234.9 recurring is the largest number we could be, and so those are our limits. And that's why we call them limits of accuracy. When we talk about error intervals, that's just a way we express the limit of accuracy so it's easier for everyone to understand. It's shorter, it's mathematically communicated, so rather than me having to sort of explain it in words, we explain it using numbers and letters and symbols. So let's just go back to this limit of accuracy, and you will notice one thing, and that is that I've changed the upper bound to 235 instead of 234.9. And we've just looked at the fact that that's not actually correct, because 235 would round to 240. So we know that's not right, but the limit of accuracy has a solution for us, and that's the way we write it. So the error interval is saying that in order for us to get our 230, but obviously it won't always be 230 depending on the question you get, so we just use the letter X to represent any number. The lower bound is 225. And we're saying that X is greater than or equal to, notice the inequality symbol I'm using here, X is greater than or equal to 225, or 225 is less than or equal to X. However, on this side, notice I've not included the equals to symbol. So we're saying X has to be strictly less than 235, meaning it can be anything up to, but not including 235. So it can be 234.9 recurring, but it can't be 235 because we've not included that equals to. So that's how we get around this little technicality here. And really all this does is makes it simpler for us, because hopefully what you will notice is to get to the lower limit, I've subtracted 5, and now to get to the upper limit or the upper bound, I've added 5. It saves all that fiddly bit with the 4.9 recurring. So it really just simplifies the problem for us, and by using this symbol, it solves the problem for us, which does make our life a bit easier. Now I've got a little table just to help you out here. Limits of accuracy and error intervals. So depending on what you are rounding to, so you want to look in the middle of the table first, that will tell you how to find your lower bound and upper bound. So if I'm rounding to the nearest 1,000, you can almost think, split that in half and send half of it to the lower bound and half of it to the upper bound. So for the lower bound, we subtract the 500, but the upper bound, we add the 500. If I'm only rounding to the nearest 100, half of that would be 50. So for the lower bound, I subtract 50. For the upper bound, I add 50. And hopefully you can see that pattern all the way through. And so it always works on this system of sort of 5, but multiples thereof, less than for the lower bound and added on for the upper bound. And we've got an example here. A number rounded to 1 decimal place is 12.4. So the number in the middle is 12.4. And so if I'm looking at 1 decimal place, which is here, for the lower bound, I want to subtract 0.05. And now this is why for some people I've suggested maybe a calculator would help, but not essential. So the lower bound would be 12.35. That's the smallest number that will round up to 12.4. And the upper bound would be 12.45 because I'm adding on 0.05 to that number. And again, notice my use of that inequality symbol without the equals to, because technically we know that 12.45 would round to 12.5, but we're saying we're including every value up to, but not including 12.45. So let's have a look at some questions. A number is given as 5,200 to the nearest 100. So just a reminder, if you're rounding to the nearest 100, half of 100 is 50. So for the lower bound, we will minus 50, and for the upper bound, we will add 50. What are the lower and upper bounds? So this one's actually only asking for the lower bound and the upper bound. It's not actually asking for an error interval. So the lower bound, if I subtract 50 from that number, would be 5,150. And the upper bound would be 5,250. And in an exam, you would get away with writing 5,249.9 recurring if it's just asking for the upper bound, not necessarily if it's asking for the error interval. Here's one for you to have a go at. Pause the video just so you've got long enough to have a go at it, because I'm going to jump in straight with the solution and hit play when you're ready. We're looking for a lower bound and an upper bound. Now your question said a number is given as 12,000 to the nearest 1,000, which means half of 1,000 is 500. So for our lower bound, I need to subtract 500. And for our upper bound, I need to add 500. A length is measured to 2.6 metres to the nearest 0.1 metre. So half of 0.1 is 0.05. So for the lower bound, we'll subtract 0.05, and for the upper bound, we'll add 0.05. So our lower bound would be 2.55, and our upper bound would be 2.65. Here's another question for you. Pause the video and hit play when you're ready to hear the solution. A mass is measured at 14.8 grams to the nearest 0.1 of a gram. So that's the same as the example in terms of what we will add and subtract. Notice this is also the same as saying is rounded to 1 decimal place. So for us to find our lower bounds and upper bounds, we need to subtract 0.05, which would give us 14.75 grams. Just realised I forgot my metres over here. There we go. And for the upper bound, 14.85 grams. If a number is rounded to 2 decimal places and is written as 3.14, what is the error interval? So notice this time it's asked for the error interval, which means I'm going to set myself up with my inequality ready to go. So before I've even thought about my numbers, it's always good practice to get yourself set up with what your answer should look like, so you know you're aiming towards the right thing. So 2 decimal places would be the same as the nearest 0.01. And so for our lower bound, we'll be subtracting 0.005. And for our upper bound, we will be adding 0.005. 0.005. So if I subtract 0.005, I'll get 3.135 as the lower bound, and if I add it, I'll get 3.145 as our upper bound, and just remembering to use that strictly less than inequality when referencing the upper bound. Here's one more question for you to have a go at. Once again, pause the video so you've got time to complete it and hit play when you're ready to hear the solution. So once again, I can see that we are being asked for an error interval, so let me get set up here. Now, if I'm rounding to 3 decimal places, that would be 0.001, for example. So half that, split it either way, so I'll be subtracting 0.0005 for the lower bound and adding 0.0005 for the upper bound. So our lower bound is going to be 26.347.5 and our upper bound is going to be 26.348.5. Well done if you got that one right. That one was a little bit tricky with all of those zeros. On to some multiple choice questions now. I will pop a timer on screen. However, if timers don't work for you, feel free to just ignore it and pause the video, use whatever time you need, and then hit play when you're ready to see the solution. We've got, if a number is rounded to the nearest 10 and written as 110, what is the error interval? Here are your options. The answer to that one was C. Your next one. If a number is rounded to 1 decimal place and written as 56.7, what is the error interval? Here are your options. That one was A. And finally, if a number is rounded to 1 significant figure and written as 4,000, what is the error interval? Here are your options. Possibly a little bit trickier on that one, because 1 significant figure for a number in the thousands is the same as rounding to the nearest 1,000, so you had to remember to split 1,000 and subtract 500 and add 500, meaning your answer was D. The final bit for you then today, just 5 questions if you wish to get a little bit of independent practice, and as you know, I always recommend that you do. The best way to get better at maths is to practice maths. So here are 5 questions. Pause the video so you've got plenty of time to have a go through these, and then I will be popping the answers on the screen in just a few moments so you can check your answers. So pause now and hit play when you're ready to see them. And here are those answers. So do check those carefully, make sure you're on the right lines. If there's anything you're not sure about, be sure to go and watch those examples again. Or if you want me to explain anything further, feel free to drop a question down in the comments below. We do aim to answer every question and comment related to the content of the video. All that's left to be said is a big well done for taking part in this video lesson. Every little bit extra that you do will help you greatly when it comes to success in your GCSEs. Make sure you are subscribed so you can find us for more video lessons, or if at any point you have any questions and need any help with preparing for your exams. If you also enjoy short form content like revision, quizzes and tips, we are also on Instagram and TikTok, so feel free to go and follow us over there. Thank you so much for watching this video. I'm Charlotte. I'll see you in another video very soon.